histograms have been a part of our statistics syllabus for quite some time. And so what we know is that a histogram is different from a bar graph in that there are no spaces between the bars. And that's because the data runs on from one class interval to the next. So for example here, this first section here, 7 people spent between 0 and 30 minutes in the gym last week. And then right next door to that, we've got these 12 people who spent between 30 and 60 minutes in the gym last week. And so what we've started doing is no longer labeling with such complicated x-axes anymore. We can simply say, well, if this is everything up to 30, and then this is between 30 and 60, we can definitely simplify the way we label these axes. So here I have the exact same histogram, but a far simpler x-axis here. So I can still see the same information. Between 0 and 30 minutes, 7 people spent that much time in the gym last week. Between 30 and 60 minutes, 12 people spent that much time in the gym last week. So that's the first thing I want to touch on, is just when it comes to drawing histograms, which are not going to get asked that often anymore. We are now going to be asked to work with frequency polygons, but if we do get asked to draw histograms, then rather just label using the class boundaries. Okay, let's shift our focus now to frequency polygons, which is definitely one of the easier sections, I find. What we have to do is find a way to represent this data here in it's almost like a broken line graph that helps us to identify how the data is spread out. So that's the goal of a frequency polygon, is to identify how data is spread. And the mathematical term that we like to use here is the skewness of the data. So if we are asked to draw a frequency polygon, what you can do is you can draw a base histogram, and then from there you can just anchor each of the midpoints, or you could skip the base histogram completely and just work with midpoints and frequencies. Okay, let me show you what I mean. Let's first work out the midpoints here of each class. So 0 plus 30, that's 30 divided by 2, gives me a midpoint of 15. Then 30 plus 60 is 90. 90 divided by 2 gives me a midpoint of 45, and so on. So 75, between 90 and 120, 105, and then finally 135 is the midpoint there. And then with these midpoints, we can plot the frequency there of 7, the frequency there of 12, and so on. So you're plotting midpoint and frequency in each instance. And then finally, you pick up your ruler and you draw a frequency polygon. And there we have it, a frequency polygon of the time that people spent in the gym. And now what I can do is I can look at the shape of this and say, well, it seems to reach its maximum here in the middle, and then it tapers off relatively evenly on both sides. So this data, if I had to really push, I would say is possibly slightly skewed to the left, but it is very close to symmetrical. But before we get into the nitty-gritty of how to actually describe the spread or the skewness of data, let's take a moment to refresh our memories on the box and whisker plot, because that is often where skewness gets tested. Okay, hopefully you can remember from grade 10, this is what a box and whisker plot looks like. It is essentially 2 boxes joined by 2 little lines. Okay, very important in a box and whisker plot that a lot of my students forget is that we need to include a number line. So this is maths, this is high school maths, so we can't just draw a little creative art project. We need to accurately measure each of the things that we plot. Now when we work with a box and whisker plot, we plot what is known as the 5-number summary. So the minimum and the maximum values, that's 2 of the 5. And then we plot quartile 1, quartile 2, and quartile 3. And now you should remember quartile 2 is also known as the median of the data. Okay, and we can work out the positions of each of these. So quartile 1, remember we can say 1/4 of the number of data scores plus 1. Okay, this is the position. This is not quartile 1. Okay, the median we can say is halfway, so 1/2, or you can say 2/4 because it's the second quartile, multiplied by the number of data scores plus 1, so that's the position of the median. And then finally the last quartile, that is a very similar position here. So we'll take, this is 3/4 because it's quartile 3 times by n plus 1. So there we have it, the 5-number summary: minimum, quartile 1, median, quartile 3, and maximum. So now that your memory has been refreshed, let's have a look at how frequency polygons and box and whisker plots can tell us about the skewness of data. Okay, so if we look at this polygon here, it has what is known as a perfect bell-shaped curve, and this box and whisker plot is so super symmetrical. So 25% of the data sits here, 25% there, 25, 25. Okay, now that's true for every single box and whisker plot, but it looks so evenly spaced out. The 25% here has an exact same spacing as the 25% here. And so data that looks like that is known as symmetrical data. Then, if you look at the second option, what would happen if we were to draw a frequency polygon here is that you'd start to see a long tail emerging on the right-hand side. Okay, and wherever the tail is, that's where the data is skewed. So in the same way, we can see the tail here. So this data is known as skewed to the right. Okay, and in the same way, I've got 25% of my data clustered together there, 25% of my data squashed together here, and then this 25% is living nice and spread out, as is this. Okay, so skewed data still contains a quarter, because it's between two quartiles. It still contains a quarter of the data per section, but in this instance, as you see it more spread out, that's where the skewness is. Okay, and this is also known as positively skewed. Right, and then finally, the opposite of that, if I were to draw a frequency polygon here, it would look something like that. Okay, and so the long tail is now on the left-hand side. So this 25% of people here is far more spread out than this 25% represented there in the upper quartiles. So this data is going to be skewed to the left or negatively skewed. So definitely a nice logical approach, and it is nice to see how the frequency polygon links to the box and whisker plot in each instance. So they can really ask us skewness in any way, shape, or form, and we just need to have a good understanding so that we can get those marks. Let's try an example together. It says here the length in centimeters of 15 pieces of spaghetti is recorded below. So there we have our spaghetti, and the first thing I do is I check, is it listed from shortest to longest? And it does seem to be in order, which is great news for us. Okay, question 1, write down the 5-number summary. So 5-number summary is all about measures of position. So if this data was not in order, my first port of call would have been to put it in order. Okay, 5-number summary, what are we dealing with? We are dealing with a minimum, quartile 1, quartile 2, which is also known as the median, quartile 3, and a maximum score. Okay, so that's what I need to work out. All right, I'm going to need to work out the positions of these 3, but the minimum and the maximum I can see straight from looking at this data set. So the lowest score there is 26, and the highest score there is 39, or rather, the shortest piece of spaghetti is 26 centimeters, and the longest piece is 39 centimeters. Okay, now to get to my quartiles, the first thing I want to do is work out the position of each of them. So remember, For quartile 1, I'm going to say a quarter, and then it's n plus 1. So there are 15 pieces of spaghetti. So n is 15. 15 plus 1 is 16. So what's a quarter times 16? That's going to give me position 1, 2, 3, 4. There we go. That is quartile 1. Then quartile 2, or the median, is a half times n plus 1. So a half of 16 is going to be the 8th. So if that was 4, 5, 6, 7, 8. It's there. That's 32. That's going to be quartile 2. And then I'm pretty sure you're starting to see a trend now where you're saying, well, we can just do 4 again. But let's do the recipe here. So 3 quarters times by n plus 1. So times by 16. 3 quarters of 16 is 12. So that's 8, 9, 10, 11, 12. There it is. The number 35 is quartile 3. Okay, so in each case, I've worked out the position. It doesn't mean that 4 is my quartile. No, no, no. It's the data score that is listed in the 4th position. So 28, 32, and 35. There we have our 5-number summary. Okay, now they say draw a box and whisker plot to represent this data. So don't be tempted to go, cool, here we go, I'm done. Remember, this is maths and we need to be accurate. So the first thing I do is I draw a number line, and now I'm ready to plot. The minimum value here is 26. So let's get that going there. 26. The maximum value is 39. That's over there. And then quartile 1, we're plotting at 28. Median at 32. And quartile 3 at 35. Okay, let's pick up the ruler and get this thing drawn nice and neatly. There we go. So that's our box and whisker plot, nice and accurately plotted. Now if I have a look at it, to me, I also like to just interpret the stats a bit. So I'm checking, is there anything that might be an outlier? Because remember, we can actually determine whether or not something is an outlier by saying is it 1.5 times away, 1.5 times the interquartile range away from either quartile 1 or quartile 3. So there are all these things, but this looks pretty well, or pretty accurate. It doesn't look like anything is throwing us too much. So our minimum value there was 26. Quartile 1 was here at 28. Our median, quartile 2 was at 32. Quartile 3 was at 35, which is already measured there. And then 39 was the maximum score there. Okay, and then finally they say to us, describe the skewness of the data. Now this is not an easy data set to describe. What I can see is that we've got a longer tail here. So I'm tempted to say, is this skewed to the right or positively skewed? But I'm not 100% confident because, as you can see here, this section is much more clustered than this section. So it almost feels like short, long, and so I don't want to just make any rush decisions. So what I'm going to do, instead of just guessing, is I'm going to, now that I've got good calculator skills, I'm going to type all of these values into my calculator, and I'm going to work out the mean. And then I'm going to decide, well, what's the difference between the mean and the median? And from there, we're going to make a proper mathematical conclusion. So X bar, type them all into the calculator. Let's see, we're going to get a mean there of 31,73 centimeters. Okay, so that's the average length of the pasta. And then we said here that the median was 32. And so that means we can conclude, therefore, the median is greater than the mean. And this is one of the most accurate ways that we can interpret the skewness of data. So if the median is bigger than the mean, then the data is actually negatively skewed or skewed to the left. Okay, it is really hardly bigger though. So you could make an argument also for symmetrical data. But generally, when this question comes your way in a test or exam, it will be very obvious. And you will be able to say with confidence, it's skewed to the left or skewed to the right.